Welcome back to the course on Mastering C++20 features. In this lesson, we will look at the relation between ranges and containers. In this lecture, we are going to start understanding thoroughly what C++20 ranges are. We will look at examples of standard C++ containers that qualify as C++ ranges and standard C++ containers that do not qualify as C++ ranges. Then, with the help of constraints and concepts for C++20 ranges, we will see how the standard identifies compatible ranges for its algorithms. And then I will add some closing points to understand how to use the ranges library. One point to note is that when I say containers that qualify as ranges, I interchange it with the fact that containers are compatible with ranges algorithm. We will understand this point in a few minutes as the lecture proceeds. If I search the meaning of the term range on internet, I get the following definition. The first one is the area of variation between upper and lower limits on a particular scale. And the second one is a set of different things of the same general type. If you have been using STL containers like std arrays, std vectors, std maps, etc., you can probably identify with the second meaning of these containers, which are intended to store collections of different objects of the same general type. In C++, ranges are also, in general, the STL containers that we have been using for a couple of decades now. Ranges are just a new way of looking at containers. However, not all the containers can be classified as ranges. Only those containers that have begin and end iterator pairs can be classified as ranges. Technically, a range container must provide a begin iterator and an end sentinel. The idea behind this is that begin iterator and end sentinel must not be of the same type. We will look at the details of this in the upcoming lectures. In reality, there are no new containers in the namespace std ranges. The namespace std ranges provides only new algorithms, and these new algorithms works with the existing standard C++ containers. That is, only if the containers qualify to work with the ranges algorithm. This will become clear in a few minutes when I move to code demonstration. But before I proceed further, I would like to mention again in this and in future lecture, whenever I say if a container is a range, I always mean the specific container will work with the new C++20 ranges algorithm. Because as I mentioned earlier, there are no new containers in the ranges namespace. On the top of the file, I have included the fmt/ranges header to enable printing of ranges without using the for loop. You can download this library from this link and compile it with your code and use it for your experiments. Next, I have included the ranges header. The reason for including this header is to include the C++ concept called ranges/range, and this concept looks like below. This concept checks if a given container represented by the template parameter t can be used with begin and end iterator functions, which will be possible only if the container itself provides begin and end iterators. Let me remove this because we don't need this. This concept is already provided in the ranges header. Next, from line number 10 to line number 26, I have included the headers for all the STL containers, so that I can demonstrate which of the existing standard containers qualify as ranges, or to be more specific, which of the standard containers can work with the ranges algorithm. So now in the main function, we can start checking if the STL containers qualify as ranges. We can do this by simply substituting the template parameter t in the ranges range concept parameter list. Let's try this out with our favorite container, std vector. Let me start typing the code. While I'm at it, let's also check if the containers std map and std unordered map are also ranges. If I compile the code and run the executable, we can see that all the three containers, that is std vector, std map and std unordered map, they qualify to work with the ranges algorithm. This is because these three containers provide begin and end iterators. Now let's look at some of the containers that do not qualify to work with the ranges algorithm. We know that std stack, std queue and std priority queue do not provide begin and end iterators in their containers. This is because they are not actually containers, but instead they are container adapters. So they should not work with the ranges algorithm. Let's try to verify this with the code. Now if I compile the code and run the executable again, we can see that the stack, queue and priority queue, they do not qualify to work with the ranges algorithm. The result of testing with the ranges range concept on these three containers results in false. The reason for this is, as I explained earlier, that these three containers, they do not provide begin and end iterators. Here's a summary of the code demonstration on the slide. I'll skip reading this slide since I explained everything in the code. You can pause the video and go through the slides. In summary, ranges are containers that have ownership of its elements. In the last code demonstration, we looked at the C++20 concept called range angle brackets T that verified if a given STL container could operate with a C++20 ranges algorithm. This concept was only one of the more than 10 existing concepts that has been introduced in C++20 ranges. For example, some of the other constraints for ranges are output range, input range, forward range, bidirectional range, random access range, and there are few more constraints that I cannot currently fit into the slides. But we will look at all of them in the future lectures in detail. The reason for having such elaborate constraint definition is that not all the algorithms works with all existing STL containers. For example, ranges : sort algorithm will not work with std list and std forward list containers. And these new constraints are built into the ranges algorithm, which ensures that each of the ranges algorithm receives a compatible container as parameter to operate on. And in case they are not compatible, these constraints give somewhat readable compiler error that will help an application developer figure out the best ranges algorithm for a given data structure. Before I end this lecture, I would again like to emphasize a few more points that were already covered in the code examples and in the previous lectures. Ranges in C++20 are provided in the new header called ranges, which we should almost always include when using ranges algorithm. And to use the ranges algorithm, we need to scope the algorithms with the namespace std : ranges or std : ranges : view. Even though most of the ranges algorithms are in the algorithm header, the reason for having new namespace is to not conflict the usage of ranges algorithm with the existing STL algorithms in the algorithm header, and at the same time maintain backward compatibility with pre-C++20 code that uses STL algorithms. That was all for this lecture. I covered a lot of information that is actually very crucial to understanding ranges library correctly. I encourage you to watch this lecture again to build a solid foundational knowledge for the C++20 ranges algorithm. Stay tuned for my upcoming in-depth lectures on C++20 ranges. Thank you.